The advantages and limitations of digital systems over analog systems are like the digital systems are used because they provides the noise immunity. The noise immunity is nothing but the amount of noise which the digital systems can tolerate without changing its output. What I mean by this point is that if there is some variations in the input signal, still the variations will not be treated as variations but will be treated as the logic 1 or 0. These variations should be in a particular range as designed by the designer. So, the digital systems provide better noise immunity compared to the analog systems. That is why the digital systems has dominated the analog systems. This is the biggest advantage of using digital systems. That is, they provide very high noise immunity. Apart from that, other advantages of digital systems are that these digital systems can be designed with greater accuracy and precision. The reason is that we only have two levels of logics. So, if we want to design an analog circuits, then we have to take into consideration the various values the analog signal can take. And as we know that the analog signal can take infinite number of values in the range. It can take any value in the range. And if the signal can take any value in the range, then the design of the system which can handle the system which can handle the signals will also be complicated and will also be less accurate and precise. Whereas if the system has to handle only two levels, or if the system has to handle less number of levels, then the system design will also be easy and will also be more accurate and precise. This is the reason because of which the digital systems are more accurate as well as precise and are simple and easy to design. Moreover, the digital systems, I should say, in the digital domain, it is very easy to store the data because in analog signal we have to store all the amplitudes at all the frequencies. But in case of digital signals, although we have to store the signals, but we have to store only two levels, and that becomes quite easy and also cheap to store. So, the digital systems are not only provides greater accuracy and easy to design, but it is very easy to store data in the digital domain. And the design of digital circuits is also more versatile. So when we say that it is more versatile, it means that the design can be used for many applications. Whereas in case of analog circuits, if the analog circuits is designed for a particular application, then it can only be used for that application. Whereas the digital ICs are very versatile and can be used to perform operations which are not even thought of. That is why these digital ICs are very versatile. And as the digital as in the digital electronics, we have to work only at two levels, that is 0 and 1. So all our components or the transistors are used in as a switch in the cutoff mode or in the short circuit mode. So the switch is either on or off. That is why these systems are also fast. Furthermore, the fabrication of the digital circuits on ICs is also very cheap compared to the fabrication of analog circuits on the integrated circuits. This particular point will be more clear when we will go through the course like VLSI. Apart from that, these digital circuits are more reliable compared to the analog circuits, and the reason for that is also more or less related to noise immunity. So if the circuits are more immune to noise, then their operation is also more reliable. That is, the circuit will perform as designed. If any circuit will perform as designed for longer period of time, then that circuit will be called more reliable. So the digital circuits are more reliable. But the digital circuits have the biggest limitation also. And this limitation is that in the real world, the digital signals are not available. In the real world, only analog signals are available. And if we have to process any natural signal, then we need to have analog signals. But as we know that the digital signals provide many advantages, so what we do is once we get the analog signal, we convert it to digital signal and then process that digital signal with the help of digital systems. And later on, after the whole process is over, we again convert it to the analog signal. Though this process is time consuming, resource consuming, as well as it becomes little slow, but as in the real world the digital signals are not available, we have to do this thing, and by doing this we take the advantage of digital systems. So moving on to the next slide, as we know that in the digital systems there are only two levels, but we have to study in this course various number systems. Although computers works on binary number system, whereas the human works on digital system, decimal number system. So if human beings know decimal number system and computers are comfortable with binary number system. So the usual question arises is why so many number systems we have to study. The reason is very simple, and that reason we are going to discuss in the next slide. But the various number systems which we have to discuss in this particular lecture are decimal number system, binary number system, octal number system, hexadecimal number system, or it can be any number system of your choice with any number of symbols. So, how to handle this number systems, various number systems, and how to convert from one number system to the another number systems. So, we are going to see this in this particular lecture. So, first point is why so many number systems are to be used at the first place? What is the reason? The reason is human beings use decimal number system because decimal number system have 10 symbols, and for human beings it is very convenient to multiply, add, subtract or divide in tens, in the number of tens. It becomes very easy for human beings to handle this 10 digits. That is why we use decimal number system as a human beings. Whereas for computers, it becomes very convenient to use binary number system. Why binary number system? The reason is because it have only two levels to handle. If you have only two levels to handle, then the presence of something can be denoted by 1, whereas the absence of something can be denoted by 0. There are only two options available. Whereas in decimal number systems, we have many options available. So, binary number system is convenient to computers, whereas decimal number system is convenient to human beings. But then why we have to use other number systems, octal and hexadecimal? We know the reasons now that why we have to use decimal number system and binary number system. But what is the reason to use octal and hexadecimal? The reason is very simple. See, if we have to use only binary number systems, then the binary number systems as have only two symbols. Each symbol is called a bit. And if you have to represent certain number in decimal number system into the binary number system, then the length of this number will be very large, and it will be very difficult for a person to remember that number. So, these number systems work as an intermediary between humans and computers. If we convert the binary number system to octal or the hexadecimal number system, then the length of the number becomes very small. The lengths get reduced, and therefore it becomes very easy for humans to remember those numbers. And why we have to remember those numbers? Because the numbers are usually used to represent various codes. In computers, as you use keyboards, let's say, so every key is coded with a certain code. It has certain code, and that code is usually called an ASCII code. We have to handle 64-bit word length. So that 64-bit word length is very difficult for human beings to remember. To make it easy to remember these codes, we use to convert them and to convert them in octal or hexadecimal number system. Hexadecimal number system is more convenient than the octal number system. But for small computers or the places where the number of bits are small, it is also useful to convert it in the octal number system. That is why we use so many number systems in this course to understand. And to understand that how to convert from one number system to the another number system. To start with, the various number systems are decimal number system. So the decimal number system have total of 10 symbols. So this total 10 symbols is called the base of the number system. Base or the radix. It is also known as the radix. So the decimal number system have radix 10, and the set of digits which we use in the decimal number system are 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in all there are 10 symbols which we use in this decimal number system. And if we have to represent any number, how we represent it? By writing the number and by writing this base in the subscript of the number. So whatever is written as a subscript is nothing but the radix or the base of that number. The other number system is binary, which we are going to use in this course. Usually almost all the numbers will be represented in binary number system in this course. And the binary number system have a base of 2 or the radix of 2. It have only two symbols, 0 and 1. Octal number system have a base of 10. In the slide you may see it is written 10, but it is just by mistake. So you correct it. You have to correct it. The radix of the octal number system is 8. And the symbols which are used to represent any octal number system are 0, 1, 2, 3, 4, 5, 6 and 7. Whereas hexadecimal number system have 16 symbols in all. And the radix is 16 of hexadecimal. The symbols used are 0 to 9 as well as some alphabets from A to F. And here in the lower table you can see that there are how we can represent numbers from 0 to 15 in hexadecimal number system as well as in binary number system. So if we take an example, let's say a number given in decimal number system as 12. So 12 will be denoted in hexadecimal as C, whereas in binary it will be denoted as 1011. Now we have to see that how we can convert a given number in one number system to another number system of our choice. So first we are going to see how to convert a number given in decimal number system to a number system with any base b of our choice. It can be binary, that is 2. It can be octal, that is 8. It can be hexadecimal, that is 16. Or it can be any other base of our choice. 5, 6, 7, 9, 12, 15, 16, anything. So, how to convert a given decimal number into another number of our choice, another number system of our choice. The very simple method to do it is the use of general polynomial expression. So what is this general polynomial and how to use it, we are going to see in the next slide. So if we have to represent a number in any number system, then that number system can be represented with some symbols. Now let us denote a general representation. So the general representation is A0, A1, A2, A3 up to AN. AN is called the most significant bit or the MSB of the number, whereas A0 is called the LSB of the number. These are the digits or the bits, or you can call it anything else depending upon the number, but this will be only be the symbols. And after A0 you can see there is a point small. So this point, before the point we have integral part, whereas after the point we have fractional part, and the fractional part is denoted as -1, -2, -3, -4 and so on. Now if you have to represent this number in the given number system, then you have to represent that you have to multiply the face value of the number with the place value of the number. Okay, so we have to multiply this, and then to get the overall number into the decimal number system, we have to add them up all. If we add them up all, then we get the number in decimal number system. So the decimal number system will be represented, the number in the decimal number will be equal to n into b to the power n. B is the radix of the number and n is the place value. So if the number is coming at 4th place, then n will become 4. Later on it will be 3, 2, 1 and 0. And on the fractional side it will start from -1 and will go on up to the place which is given in the number system. Now let us understand this thing with the help of an example. Let's suppose I have a number in binary number system and I want to convert this number in decimal number system. The given number in binary number system is the second example, which is 1, 1, 0, 1, 0, 0.110 in the base 2. If we have to convert this number in decimal, what we have to do is represent the number in the general polynomial form. The general polynomial form is nothing but will start from the MSB. So 1, there are 5 places. So starting from the lowest side, it is 2 to the power 0. Okay. So if I'll start from the MSB side, LSB side, so then 2 to the power 0, and you can see that it is 2 to the power 0 is multiplied with 0. So we have 0 into 2 to the power 0, and 2 to the power 0, as you know, will be 1. Okay. then we have another bit as 1. So now this 1 is used here as 1. So we multiply this 1 with 2 to the power 1, because this 1 is the 1 in the power is coming because this 1 is at the first place. LSB, after LSB we have the first place. LSB is considered as the 0 place. So then first place. So in the first place that 1 is coming. Now if we keep on doing this, then the next place is 0. So in the number you can see it is 0 there. So what we do is we take 0 and multiply that with 2 to the power 2. Later on we do it with the same with the another digit, another bit on the integral side before the point. Now if we do the same thing after this point, then we have to consider as the digit, the bit, and the bit has to be multiplied with the minus power of the base. So it is 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2, then 0 into 2 to the power minus 3. And if we calculate all of them and sum them up, then we get the number as 26.75. So now the number is converted from from binary number to the decimal number. This is the way you have to convert the number given in one number system in any given number system to the decimal number system. Let's take another example. If the given number is in octal number system, then we have to use the powers of 8. So if the number given is 247.25 in base 8, then it can be represented as 2 into 8 to the power 2 plus 4 into 8 to the power 1 plus 7 into 8 to the power 0 plus, oh, I'm very sorry, this should be 2. So it is by mistake. So you make it correct, and then probably I might have made the mistake in calculating this. So this will be your work to correct it. This will be your homework to correct it. So in the next class I will talk about, you have to tell me in the doubt class, you have to tell me about this, that how you have done this, how you have corrected it. Similarly, if the number given is in the hexadecimal number system, then we can use it to convert the number in decimal number system. In the hexadecimal number system, we have to use the powers of 16. So 16 to the power 2, 16 to the power 1, 16 to the power 0, 16 to the power minus 1, 16 to the power minus 2. And these powers are multiplied with the corresponding face value. Now you can see that instead of A at the first place, I have written 10 here. Because why I have written 10 here is because in the last slide, if you will see, then you might remember that this A is equal to 10 in decimal number system, whereas B is equal to 11, C is equal to 12, D is equal to 13, E is equal to 14, and F is equal to 15. So if you get any number in hexadecimal number system and the number is something like a alphabet, then we have to represent it with a corresponding digital number, this decimal number, before multiplying it with the power of the base. Following the same procedure, if we do it, we get the number in the decimal number system. Similarly, if we have the number in a number system which have 5 symbols, and if we want to convert that number in decimal number, then we have to use the same logic. Let's say the number given is 1240.32 in the number system which have 5 symbols. So the radix of the number system is 5. To convert this number in decimal number system, we have to multiply each of the place value with each of the face value with the place value of the number. So 1 into 5 to the power 3 plus 2 into 5 to the power 2 plus 4 into 5 to the power 1 plus 0 into 5 to the power 0 plus 3 into 5 to the power minus 1 plus 2 into 5 to the power minus 2, which becomes equal to 195.72 in the base 10. And why we do this all? Because in the very first example which though I have not discussed, but you know from your this is schooling that how to represent a decimal number in the place value form. So let's say the number given is 736.27. So this number, if you want to represent in decimal number system, it is very well known to you that how you can do it. The same logic we have used here to represent all the numbers. Moving on to the next slide. Based on what we have learned so far, we will discuss a numerical, and this numerical I expect you to do the numerical. So I expect from you to do this numerical. So this will be considered as quiz, and the solution for this will be provided in the next class. You have to do the question by your own and show me the solution in the next class. So the question is, consider an arbitrary number system, that is the number system with unknown number of symbols or the unknown radix. Consider an arbitrary number system with the independent digits 0, 1 and x. What is the radix of this number system? List the first 10 numbers in this number system. So this is the question you have to do by your own. So either you pause the video and do the question, complete the question here itself, and show me it in the doubt class. So I'll ask you in the doubt class about this question, that how you have done it, and I will ask randomly to any student, and that student have to show me his solution. So I stop this lecture here itself, and the remaining portion of the number systems I will discuss in the next part. Thank you. Thank you everyone.